Hi, my name is Mark Thompson and I work for Silver Peak as a systems engineer supporting service providers throughout the EMEA region. This demo is going to focus on TCP traffic. The test is going to be run between two sites, one hosted in New York, one hosted in Vienna. I do have a WAN emulator, so this enables me to introduce impairments to any one of these links that we can see here. I have 100 megabits per second of bandwidth available between these two sites. That's bonded capacity, so I have 50 megabits on each of the broadband and MPLS links hosted from Vienna and New York. The demo will show you the benefits of application acceleration and latency mitigation via orchestrating changes as we move through and enabling boost or more traditional WAN optimization to overcome the negative effects that latency and loss can have in this environment. As this is a demo, I will start with little to no latency between these two sites. This will allow me a baseline or what you could expect between any two hosts when you have 100 megabits of bandwidth available and your application is TCP based. So as I say, there'll be little to no latency and zero loss applied via the WAN emulator when I start this test. I then will add some meaningful latency, which on average between these two sites is 100 milliseconds round trip. And as I say, I will orchestrate changes after introducing loss and latency that will overcome the negative effects of that. This is my demo orchestrator. We're looking at the dashboard view there. But what I want to do is move directly over to the topology view. I'm going to select the relevant business intent overlay called Latency Demo, which has been applied in two sites, Vienna and New York. If I click on this green link or line between the two sites, I get a more detailed view of the tunnels and transports available. Clicking on the live view will bring up a near real-time view. I'm going to monitor loss, latency and the bandwidth. And you can see there at the moment minimal to no loss or latency and the same for bandwidth. I'm also going to use the appliance view, so the Vienna appliance view. This gives me a more detailed view from a reporting standpoint based on physical interfaces and the overlays. We can also monitor many other things, but for this demo we'll just stick to the metrics you can see there. Quick view of the host that I'm using. So the client is in Vienna, the web server is in the speed test web server is in New York, and you can see there that there's little to no latency of any meaning between these two sites. I'm going to run this test 3 times. The first is a baseline to get an understanding of how TCP performs with 100 megabits of bandwidth with little to no latency and no loss that has been introduced by myself. So there you can see, yeah, what we would expect. Not quite the full 100 meg, but within reason, within 10% of the available bandwidth from a TCP perspective. I'm now going to add some latency initially to the internet link, which is E7. So I'm going to add, said 50 milliseconds there. That's unidirectional round trip. That'll equate to 100 milliseconds. 1% loss for the internet link. And then I've added 50 millisecond and 0.5% loss to the actual MPLS link. We can now see in the live view that latency between for both transports is being registered. So I've added the latency and the loss. We can now see from a ping between these two sites, I'm getting on average 100 milliseconds. Now the second iteration of the speed test, we can see what real world effects TCP traffic suffers from under normal circumstances, and this is how all applications, regardless of the bandwidth available, you could have 10 gigabits available between these two sites. That is the only throughput that you would actually achieve with the loss and the latency that I've added to this test. And you can see if we look at the actual appliance view, you can see the dramatic effect that's had on the actual line graphs representing the various interfaces and overlays. Again, we see that loss represented in the live view. And now what I'm going to do is I'm going to orchestrate some changes to the overlay in question, which is the Latency Demo. Well, I'm just showing you that each and every one of these overlays, business intent overlays, has its own unique set of configurations. I've selected a high quality overlay that's going to introduce forward error correction to correct for that loss. I've also enabled Boost, which will perform application acceleration, deduplication and compression to the available traffic. It is important that all these changes are applied before I run the third test. You can see here we've got an estimate of the time it will take to complete these changes, but it's usually around about a minute. Okay, so all those changes have been applied by our REST API. And now we can do the third iteration of the test. I'm going to restart this with those changes to the business intent overlay applied. And I'm sure you can see that there's a rather dramatic difference between these results and the previous results. We can see the effect of that on the actual detailed reporting. So hardly registers the test when I ran with the latency, but no orchestrated changes. And after the changes, you can see there that the LAN has experienced roughly a gigabit worth of throughput. A summary again, just going back, this is the baseline. This is the kind of real world with lost latency, but no business intent overlay protection. And this is with the business intent overlay applied, or the changes to the application acceleration applied. One final test that I'd like to show you here. The previous test just showed a single flow between a browser and a web server. I'm now aggregating 5 streams between those two sites. It's TCP traffic again. And you can see that the aggregate bandwidth we're able to achieve now from a throughput perspective, if you're looking there at the LAN, that's roughly 1.5 gigabits of throughput we're now getting on a link that is only physically capable of supporting 100 megabits, but with real loss and latency, TCP can only actually experience between 5 and 10% of the available bandwidth. Thank you for your time. If you need more information from Silver Peak, then please reach out to your local account managers or visit our website and request some additional information there. And you can also always contact me directly via LinkedIn if you're unable to contact your local sales contact. Goodbye.